Welcome to another video for chemistry. In this video we're going to be discussing limiting reagents. So when a chemist carries out a reaction, the reactants are usually not present in exact stoichiometric amounts. What that means is that when we do labs, it is virtually impossible to have, on the reactant side of your equation, it's virtually impossible to get every single element or molecule to react with the other reactant that you're mixing it with. You're always going to have something left over. Because you're talking about such an enormous amount of elements that are involved in each of your compounds, like I said, you're not going to get all of them to react. Okay? There's always going to be something left over. So some reactants will be left over at the end of the reaction. The reactant used up first, okay, now this is important, the reactant that is used up first in the reaction, that is called your limiting reagent. So if you have one reactant that's used up, that means that another one is not used up completely, and that will be your excess reagent. Okay, so the amount of product that you end up with depends on the amount of limiting reagent that you have. Okay, so because the maximum amount of product formed depends on how much of this reactant you have. Okay, now the excess reagents are the reactants present in quantities greater than necessary to react with the limiting reagent. So that's the reactant that you're going to find that you have extra of. That's going to be the leftover. That's the excess. So if I was to make an analogy of this, I'm going to use tires and cars. Okay? So let's say I have 16 tires. Okay, and as you well know, it takes 4 tires to make a car. So the question is, oh, well, before I get to my question, and let's say I have 6 car bodies. So again, I have 16 tires and I have 6 car bodies. And the question is, how many cars can I make? Well, I'm limited by my 16 tires. Because I use up all the 16 tires, there's nothing left, and I can make 4 cars, but I'm left over with 2. I have an excess of 2 car bodies. So my limiting reagent in this case would be my tires, and my excess reagent would be my car bodies. All right, now let's actually look at a chemistry example to see how this works. So consider the industrial synthesis of methanol, CH3OH, from the carbon monoxide and hydrogen at high temperatures. So carbon monoxide and hydrogen will combine at a high temperature to make methanol. All right, and this is actually a balanced stoichiometric reaction or equation. Okay, so this is balanced equation. So which of these quantities on my reactant side is the limiting product and which is the limiting reagent? Okay, now let's say in a chemistry lab, I have 4 moles of carbon monoxide and 6 moles of hydrogen gas. The reagent or the reactant that produces the fewest moles of the product is the limiting reagent because it limits the amount of product that can be formed. Okay, so if I go back to my car example, like I mentioned, my tires were my limiting reagent. Okay, they were limiting reagent because they limited the amount of cars that I could actually put together. Because I ended up with 2 car bodies that were in excess, so the car bodies were my excess reagent. So again, whichever one of these two, carbon monoxide or hydrogen gas, produces the least amount, they are the limiting reagent, just like the cars and the tires. The tires were my limiting reagent because they limited the amount of cars that I could put together, which was 4. Okay, so I need to find out how many moles of methanol 4 moles of carbon monoxide and 6 moles of hydrogen gas will produce. So I'm going to run this through to see which produces the least. All right, so the relationship between carbon monoxide and methanol is a 1-to-1 ratio. Okay, there is a understood one, an assumed one here, right? So 1 mole of carbon monoxide will make 1 mole of methanol. It's a 1-to-1 ratio. That's pretty easy. So in my conversion equation, at the bottom I'll have 1 mole of carbon monoxide, and the reason I have 1 mole of carbon monoxide on the denominator is because that is the unit that I want to get rid of in my given. So you have 4 moles of carbon monoxide. Well, I want to have the mole of carbon monoxide on a denominator position so I can eliminate that unit and get my desired unit of moles of methanol. Okay, so 1-to-1. So it's basically 4 times 1. 4 times 1 over 1, which is 4 moles of methanol, just like I concluded there earlier. So I have 4 moles of methanol. Now I need to find out how many moles are created with 6 moles of hydrogen gas. So the relationship with hydrogen gas to methanol is a 2-to-1 ratio. So for every 2 moles of hydrogen gas, I produce 1 mole of methanol. So again, I want to have hydrogen gas in my denominator position because that's the unit I want to get rid of, and I want to get the unit of methanol. All right, so moles of hydrogen gas cancel out, giving me 3 moles of methanol. Okay, so 6 moles of hydrogen gas give me 3 moles of methanol. Now, so again, which produced the least amount of methanol? Hydrogen gas. So that means hydrogen gas is my limiting reagent in this case. Okay, and that makes carbon monoxide my excess reagent. I'm going to have extra carbon monoxide left over after this reaction is complete. Okay, that's a quick look at limiting reagents, and stay tuned for the next video where we will go more in depth in how to find these limiting and excess reagents. Good luck in your studying.